Hey guys, welcome back to AlgoYogi. We are now doing stack series, and today we will be solving final prices with a special discount in a shop. So let's go to LeetCode and give it a read. This is, I would say, one of the most practical problem that I've seen so far. So let's go through it. You are given an integer array prices where prices I is the price of the ith item in a shop. Quite clear. There is a special discount for items in the shop. If you buy ith item, then you will receive a discount equivalent to prices j at the jth index. That's the discount you will receive as long as that is a minimum index that's right next to basically the closest element to ith element. That is basically greater, j is greater than I. So j has to be next to I. It has to be next element to I. Also, it has to be, its price needs to be smaller than ith price. So whatever j we are going to choose, it has to be closest towards right of I, but also its price has to be lesser than or equal to price I. All right, now we need to return array answer, where answer I will be returning an array of same size prices. Now answer I is the final price you will pay for the ith item of the shop considering the special discount. So basically there is prices array represents the item's price for all the items in the shop. Now we need to return another array which is answer, which will have all the prices. So this is what we need to return. We need to return an array called answer, where answer will so let's index these elements in prices. So 0 1 2 3 4. We will have same length array 0 1 2 3 and 4. Now now we need to calculate how much final price we will be paying for each of these prices. So if this is 8 right now on 0th index, so how much price do I need to pay? So I need to check the closest element towards its right, the jth I need to choose jth index that is towards right. It has to be just closest, but another condition is, let's write it down. Another condition is prices j that we are choosing has to be less than or equal to prices ith. Okay, this is also a good condition, and then j has to be greater than I. Okay, they can't be same. You can't ask a discount for the same same index. You can't be like at 8 and you're like, I want 8 discount. So you'll be paying nothing in the shop. It's not good for the shopkeeper. Okay, so for 8 you can see this particular index, one index which has the price of item is 4 is lesser than the price of 8, and also it's closest to 8, so which is like if I'm choosing j as 1, then it's j is greater than I, and also its price is lesser than the ith price. So both of these conditions are satisfied. So what I'll do is, to calculate the answer, I will basically here at 0th index, it will be 8 minus 4. This will be 4. Now what about 4? What is that closest element towards right that is smaller than it? That is 2. Okay, 6 is greater than 4, so it's 2. 4 minus 2, it will be 2. What about 6? 6 has 2, so this will be basically 6 minus 2, it will be 4. How about 2? 2 does not have any smaller elements than 2 itself next to it. So it's going to be, we'll be paying full price for it. So it will be 2. How about 3? 3 doesn't have any item next to it. So we will pay the full price. So this is the array. This is the answer that we will be returning, and this is the price after discounts, after applying the discounts on all the items we will be paying. So how do we calculate that? How do we actually calculate that? So now I see the brute force approach right here will be that I create my answer array. We already have that. So I'll create my answer array, and for each I will start searching my j starting I plus 1 and check for the jth item which is smaller than my current item. Wherever I find that, I will come back and basically calculate. I will use that item to calculate the final price after subtracting that index price from my current item that I'm calculating the discount for. So I'll do that. I think we have already went through that particular walkthrough, so you know what I'm talking about. But this will be a solution of big of n square time complexity, because for each item I'm trying to find another item that has the index greater than my current item, and also the price has to be lesser than or equal to my current item. So this will be big of n square time complexity. Can we do better? Yes, we can. How do we do that? We're gonna use stack. We're gonna use stack to basically calculate our answer. So how do we do that? Okay, let me show you guys. So what we will do is instead of traversing again for each item to find its next item that has the price lesser than or equals to it, so what I would rather use an extra memory, which is a stack, and I will traverse from the back of the array so that I can already see what item I have seen and what is their price. So whenever I'm visiting an item from back, I have already seen and stored those items price in my stack, and later I will be able to basically check for a particular item that what is the price that I've just seen, and is it lesser than the price that currently I have. If it is not, then I'm going to pop the item from the stack and then push the current item, and if there is an item that has the price lesser. So let's do the walkthrough. I think it's getting like I'm talking too much, but like we're not understanding what we're doing. So what I'll do is I will start iterating the prices from the back of the array, and I will check if my stack has something for the current element. So let's say I'm doing it for my ith element. Currently it's in the back, it's 3. Does my stack has anything? No. So that means what? I haven't seen any element before this, any item before this. So that means I will be paying the full price for this item. And then I'll push this item to my stack so that I can see for my next element from the back that I have already seen an element that has this price, and if it is smaller than the current price, then that's the discount you will be getting. Just look at the top of the stack to see the discount. Then I will move my ith to check the next element, which is 2, and I see, okay, yes, there is something in my stack. And is this lesser than my current price? If it is not, then I want to pop it from my stack. Why? Because this is greater than, or this is greater than, not equals to, this is greater than my current item price, which is 2. So since this is a smaller already, I can safely pop this item and again check if there is an element that has the value lesser than my 2. So lesser than my 2. But now after popping 3, I see that there is nothing in my stack, so I will have to basically pay the full price for this item, and also I'm going to basically push this item into my stack so that next time I see an element and I'll be calculating the discount, I will have access to 2 as an element that could be a discount, possible discount. And I have safely popped 3 out because 2 is smaller than 3. So in any case, because we are calculating the discount from right to left, so 2 will of course qualify because its index will be smaller than 4. So this will qualify before even we get to 3. So we will never get to 3. So 3 could be popped out safely. So we move on. We are now at our next element, which is 6. So I will again check in my stack. Is my stack empty? No, it is not. So what do? I will check if my current element, the top of the stack, does my stack has element, and if does my stack topmost element is greater than my 6. If it is greater, then I will be popping it out to look for a smaller element. But you see that this is not greater, this is smaller. So I will use this as discount. I will not pop it out, right? I will only pop it out if this was greater than 6. So I'll just I won't pop it out. I will use this value. So 6 minus 2 will be the 4, because 2, we are getting 2 as a discount, and we will then push 6 onto the stack, because now 6 is a value that could be a possible discount for the next value. So now we will be doing it for 4. Then we check the top of the stack. Now top of the stack is 6. This is top. Now let's check. Stack is not empty. So let's check the top. Top is 6. 6 is greater than 4. So 6 could not be the discount for 4. 4 is already smaller than 6. So we can safely pop 6 out. Pop 6 out and check if the next item is a possible discount. It is, because 2 is smaller than 4. So we will use 2 as discount for 4. So we will be paying 2 for this item, and there is one more item left. Now before moving on, I will push this to my stack. That is because 4 could be a possible discount for the next element. And now I popped 6 out because we can safely depend on 4 being the first discount. First preference will be given to the element that is right next to its element before it, which is 8. So 8's next element is 4. 4 is the top of my stack, and this is the discount that I'll be using. So I will basically pay only 4 for this item. So this is the flow that we will be using with stack. And honestly, I could write down the pseudocode right here, and then we can write down the code also. So let's write down the pseudocode. And if not, if you already understood, then you can go ahead and just implement your own solution. And if you find it difficult, then we will implement it together. But here will be the source code. So I'll have answer as an empty array. Then I will have a stack as an empty array. Then I will have for loop for I, or let's say for num in prices, and we will be basically iterating from the back of the array. And for this particular num, I will be checking if, or maybe I think while would be better. So while there is something in my stack and stack top element, we're not popping it out, we're just checking if the top element of my stack is greater than my current num, that means I can safely pop that out. So stack dot pop, and then I will come out of it. So we will keep popping until we keep seeing an element that's greater than my current num, and this is the element I'm calculating the price for, basically the discount for, final price after the discount. So what I'll do is I'll come out of this loop if there is something still in my stack. That means I've popped all the elements that were greater than my current price, but if there is still something in my stack, then I will append it to my answer. Or remember, we will be returning this answer in reversed order because I'm just appending it. I don't want to like insert, you know. Also you could insert, but I will just append it and finally return the reversed version of this. So I will have num minus the price, basically the top of the stack, which is -1. We're not popping it out, we're just using it. Else would be answer dot append. Remember, if there is no discount, you still pay the price. Which is the num value, whatever it was, the original price is, right? Original price, which is num. And finally, there is one more thing. We need to append this particular element into our stack so that it could be used as a potential discount for the next element. You're coming from right to left, from the back of the array to the front of the array. So we will just append it. Okay, this is the pseudocode. Sorry, I shouldn't have this here. Finally, let's just return. We will be returning answer in the reversed format. All right, this is the exact code we will be writing. That's it. This will be big of n time complexity, way better than n square, and space complexity will also be big of n because we have to return this answer, and also we are using a stack. All right, so it could be just, you can call it 2n, but you don't have to call it 2n because 2 is you can ignore 2. That's the rule in calculating the time complexity or the space complexity. So we're going to go back to the code editor and write down our code. So we'll have answer as an empty array. Yeah, I will be writing exact same thing that I have written in the pseudocode. So whatever you have seen over here, whatever you have seen here in the pseudocode, this is exactly I will be writing. Okay. All right. So now what do we do? Okay, I think it's in top right. Yes. So I'll have a stack which will also be empty for num in prices. Let's reverse them because we are now iterating from the back of the array, and this is in Python. This is one of the way of doing. While there is something in stack, and stack's last element which will be accessed by just peeking into it is greater than num, not equals to, just greater, then we will pop that value from the stack. Then what do we want to do is we want to now check if stack is still non-empty, and if it is, then that's the value that we're going to use for our discount. So answer dot append current num minus let's peek that value again from the stack. So stack -1. So we're just peeking, we're not popping this out because this could still be a potential discount for the next values. Else you still pay the full price. So answer dot append num, and there is one more thing in the end. This num still goes into our stack to be a potential discount for the element before it. So we will just append that to my stack. So stack dot append that num. Finally we come out and we just return answer but in reverse format. This is the way you do it. So basically this entire thing is just reversed. All right, I think everything looks good. So I'm gonna zoom out, and main scene. This is how you zoom out. I think my hotkeys are not working. I'm recording on OBS. That's the software that I'm using, and I think my hotkeys just stopped working. All right, so let's run it. Awesome. Okay, we're gonna submit it. All right. Yeah, I think I'm gonna try to submit it. It doesn't look like it, it's one of the best solution, but it is the best solution because sometimes like it's not your solution. It's just the internet speed, that decides this beating complexity. It's a perfect solution, by the way. Okay, time complexity. This is one of the rituals that we do, where we complexity. That is because this is also the ritual you follow in your actual interviews, so it's good that we practice it. Complexity will be big of n, because we are storing the answer. We also have stack, okay, so I am going to now go back to AlgoYogi and mark this problem solved. Awesome. So see you guys in the next video. Until then, bye bye.